All right, we are right at the start time, 2 o'clock Eastern Standard Time, so we'll go ahead and get started. First off, good afternoon. I am Jason Thomas, Technical Project Portfolio Coordinator at America Makes, and your host for today's America Makes TRX webinar series. A little background on the TRX webinar series before I introduce our speaker. As America Makes continues its mission to expand and accelerate the footprint of additive manufacturing and 3D printing, this medium, called the America Makes Technical Review and Exchange webinar series, was created. By creating this platform, it allows the additive manufacturing and 3D printing community to come together and share knowledge and experience with a broader community. If you or your team are interested in presenting during the TRX webinar series, there will be a link to complete the request form at the end of our series today, or you can contact the America Makes TRX webinar series administrator, Jason Thomas, directly. A few important notes before we kick off the series. At the end of the presentation, there will be an opportunity for a brief Q&A session. If during the presentation you do have a question, please submit it in the Q&A space on your WebEx screen, and I'll ask it during the Q&A session. I will do my best to get all of your questions answered. Today's webinar is on advancing state-of-the-art in AM through a flexible machine architecture. Without further ado, it is my pleasure to introduce Jorge Morales from Econity. Jorge Morales earned both his bachelor's degree in mechanical engineering in 2011 and his master's degree in metallurgical and materials engineering in 2013 from the University of Texas at El Paso. He joined the WM Keck Center for 3D Innovation in 2006 and started performing research related to additive manufacturing using vat photopolymerization and material extrusion. His early research work at the center was related to material extrusion of metal alloys and processing of novel polymers. As a graduate student and later as a research manager at the center, Jorge worked with a range of powder bed fusing technologies, including binder jetting, electron beam, and laser beam melting for 6 years, where he conducted research related to parameter development of novel alloys, in situ process monitoring, and process optimization. Transitioning away from academia, Jorge worked at Arconic Inc., later known as Cumberland Additive, for almost 4 years, where he helped industrialize AM and qualify the first titanium component to go into serial production in commercial aircraft. Today, Jorge is the managing director at Econity in the U.S., an AM equipment supplier, helping enable diverse next-generation applications in AM using laser technology. Jorge, I will now turn it over to you and your team.
All right. Thanks, Jason, for the introduction. So yes, my name is Jorge Morales, and I'm currently the Managing Director for Econity Operations in North America. Today, I plan to give a talk on some of the case studies or perhaps success stories that really showcase what can be achieved with a system that provides flexibility in both its operation and overall design, right? So first off, I know perhaps some of you may not know about Econity, so I'll spend maybe 2 or 3 slides with a quick company introduction. So as a quick overview, Econity is a machine OEM for additive manufacturing equipment that uses laser technology. Currently, we're primarily focused on laser powder bed fusion, but we have started releasing some sneak peek content on an upcoming laser wire directed energy deposition technology. Our headquarters are currently in Germany, where we offer machine assembly, feasibility studies, testing, and just overall support for our European customers. Here in the U.S., we're located in El Paso, Texas. That's really thanks to the strong collaboration that we have with the university here in El Paso. So UT El Paso is also a satellite center for America Makes. And I suppose some of the same reasons that, America Makes picked UTEP as their first satellite center are probably some of the same reasons that we set up our headquarters in El Paso. I think UTEP identified the value in our vision very early and really contributed to our success from the very beginning. So here in the U.S., we're currently primarily just offer sales and technical support, but we are quickly expanding our facility in the near future to offer application support as well. So this will include some machines to have both as a showroom and also as a manufacturing space for these application projects, right? So currently we offer 4 systems, ranging from what we call a mini system with a cylindrical build chamber of 140 millimeters in diameter by 140 millimeters in height, all the way to our large format system with a cylindrical build chamber of 400 millimeters in diameter by 400 millimeters in height. And so as you can tell by these illustrations, our systems look very much different than a typical system that you see out in the wild, right? Say an EOS, SLM Solutions, Concept Laser, or whatnot, where the design is typically a box system, right? Here you see our systems are not in a box, right, which is intentional. We made the design of our systems this way really to enable flexibility. So you have full access to the optics. You know exactly what's going on. If you need to make additions outside of your process chamber, you can easily do that, right? So I'll be a little sales pitchy on this slide maybe, but today we make it very easy for you to customize your very own laser system. You can select one of our systems and customize everything that comes along with it. So you can customize the type of laser the system uses, the scanner, the monitoring options added, the heating options, and even add some of the auxiliary equipment that you may need, right? And again, this really speaks to our flexible machine architecture and design. And last slide on our technology, just as an introduction, I added this one a bit last minute, but I think it's probably the best way I found to describe to my wife about our technology compared to typical box systems. So hopefully it helps. So hopefully we have some gamers in the audience, or maybe attendees that have kids that like gaming. But if you go out today and buy an Xbox or a PlayStation, you know, you will buy that console according to the latest and greatest technology upon its release, right? Now, over the years, you know, new technologies such as better graphics cards are released, but the consoles will not catch up until the next generation of consoles are released again, which could be years down the line, right? As you can see by the graph. So what we find in AM is that there's a lot of innovation going on, right? And so a typical box system does not typically allow for this new technology to be implemented and tested. And so this is what my presentation today is all about. You know, what success has our company had with this type of flexible approach? So now that we've made you know, the intelligent choice of purchasing a personal computer for gaming, and we did the same with AM and purchased an Econity system, we are well on our way to keep up with the latest technology, right? For our first case study, we look at new laser technology. This is an area where I think laser technology for additive is something that we will probably continue to see improve. Which was the case when we started working with Enlight lasers, right? So they released their quote unquote AFX laser system, and we were they were quickly looking for a machine that could integrate their laser and demonstrate its capability. So that's where we came in. The FX laser offers switchable beam profiles where you can achieve up to 7 different beam profiles from everything from a single mode spot all the way to a ring mode spot, right? Now, there's probably a lot more content than I can provide in this short presentation, but you can definitely reach out to me and we could have a deeper discussion later. But basically, the ring mode type approach, we think offers a more consistent energy distribution than the Gauss type spot. And so we've seen this leads to some improvement in melting dynamics, right? So some cool videos here that I hope come out okay in this webinar. On the left, you can see some possibilities of working with switchable beam profiles. In this case, we have a dual laser system, really more so to demonstrate the speed differences, but just as well, you can have a single laser system, you know, and still have improved productivity by melting, you know, the inner hatching of a part maybe with the ring mode type profile, and then the outer profile or the contour getting scanned with maybe a finer beam, like a single mode type profile to achieve a better surface finish. So this is a new concept, but it is something that I think Nlight's AFX, the fact that you can scan, with a wider beam inside the hatching is not a new concept, right? That's probably been demonstrated with a Gauss beam by defocusing that beam, right? I do think, though, it is something that the Nlight laser achieves quite nicely. But regarding the improved melt dynamics, you can see here on the right, if you were to defocus a typical Gauss profile, you would most likely get some ugly melting dynamics, right? Here you see on the top of the 400 micron Gauss profile, and then on the bottom a 400 micron ring profile. So the difference here is that you get less spatter here on the bottom. Here, I'll play that again. You do get an interesting vacuum effect, right? So you see particles kind of being sucked into the melt pool. So there's still a lot of learning to go along with this option. I think being the first adopters always helps because it gives us that expertise ahead of anyone else that may be implementing this later, right? That said, there's a lot more than we can do, specifically exploring how these energy sources affect materials processing. There's more to come on laser technology, right? There's potentially the blue lasers and just other wavelengths to explore. This is that manipulation of lasers and kind of the manipulation of the scanning of a laser is one area where we're working on a lot, and kind of achieving some of these unique strategies, which I guess leads to my next slide. The software for our machines, being a fully flexible system on the hardware also translates to our software. So we offer full control over all process parameters. And so with that comes the question, how can I manipulate the thermal processing of a part by maybe adding a second energy source, not just for productivity, but maybe to influence a certain type of microstructure and perhaps achieve a better end product that maybe requires reduced post-processing, right? Because now you have an optimal microstructure that may be better than a thermally treated part. I don't know. But here we have different options when it comes to different scan strategies. We call these the master-slave laser approach. Basically here you have two lasers kind of working together to achieve the possibility of in-situ heat treating or microstructure control, right? So you can have, one laser process in a linear fashion with a secondary laser following along with it, with like this type of wobble. And you could do that either right in line with that first laser or with a time delay, perhaps a second laser following behind or in front of it. Or perhaps you want to defocus that secondary laser and again follow that kind of along that first laser, but still affecting kind of your melt pool dynamic, your energy input that goes into your melt pool. Or, if you have a quad laser system, then can you apply all of these approaches and then see what happens to your material, right? So perhaps one of the most unique of these scan strategies was done recently with a fiber laser and an AFX laser working together, where one laser was scanning a typical laser vector, right, which you see here in the center of the video, right there. You see my mouse. While the AFX laser was following that first laser in an 8 or infinity pattern, right? Now, to my knowledge, right now we're the only ones that offer a software solution where our users can basically check a box in our software and apply this unique strategy. We're still doing a lot of characterization work here, but we encourage people interested in this type of unique scan strategy work to reach out to us if you need more information about this. Talking about, in situ preheating, another one of our unique offerings is heating going above and beyond what our typical box system can achieve, which has been around, typically 500 degrees C. In fact, one of the inspirations for creating Econity in the first place was that our founder, Yves Hagedorn, was working on processing ceramics using laser powder bed fusion for his dissertation. He quickly found that materials like ceramics cannot readily handle the very high cooling rates in laser powder bed fusion. And there wasn't really a machine option available that could accommodate that high temperature heating to, essentially reduce your cooling rate. So together with some colleagues, they developed an induction preheating option, which achieved upwards of 1,000 degrees C. So today, we've used this option to help customers, process materials that are difficult to weld or prone to cracking. Most notably, this is some work we did with Fraunhofer ILT, but we have helped process titanium aluminide, and this is a material, as many in additive know, it's notable for really only being processable using electron beam melting. So here you see a quick demonstrator and its mechanical properties, especially when compared to other technologies like E-beam and casting. We have achieved a bit of a better result, at least as shown here by strength. And so when doing work like this, it not only helps to have the hardware really to push such processing, right, enable that processing of these difficult materials, but it also helps having full control over processing parameters, right? And so this, again, transitions to my next slide. This is an area where our partner, Equispheres, which is a powder supplier in Canada, they offer, some really nice aluminum powder, great morphology, great flowability, all enabled by their proprietary atomization technology. I promise I was not paid to say that, but these guys have one of our systems, and they have been working on using our system to improve build rates and basically achieve optimum productivity in AM. So if you want more information about their powder, reach out to me, and I can certainly put you in contact with the team down there so you can chat with them directly. But on this next slide, you see here a graph showing improved build rates of specifically ALSI 10MG, where they were able to achieve build rates above 150 cubic centimeters per hour without really sacrificing on density, right? So I guess, parameter development work is not new. This has been going on with your typical box system for a long time, right? Nothing really unique, but what we offer is a software that enables full control over even more parameters, any parameter you can think of related to your hardware options. So sure, you will get access to your typical laser power, speed, hatching, and whatnot with a typical box system, but here, Equispheres, for example, gets access to a lot more, such as laser offsets, scanner delays, skywriting parameters, really garner a deep understanding or insight into everything that is affecting processability of their material. I think this has really helped someone like Equispheres. They sell powder for a living to users that likely have one of these typical box systems, and so this deep understanding basically helps ease the transition of the parameters that they have developed with our machines and essentially transition those onto other systems, right? Okay, so I guess I have two more studies or perhaps success stories again. These last two studies are primarily related to the flexibility in testing or maybe adding, evaluating new hardware and sensors. So the first one here was a collaboration with Aerosynth, which I guess they've made the news recently. But this company has a solution using a novel recoder. All right, they're able to spread two different materials onto a substrate. So you see the recoder in the image here, which basically consists of a recoder within one of our machine's process chambers. And you see two roller type mechanisms in here. So one roller will house one material and another roller a second material. These two will then be deposited selectively onto the substrate, right? And so the possibilities of creating multi-material structures can span a variety of different applications, right? Perhaps you need a secondary material for cooling purposes, say if you had a copper type material, or maybe a structural purpose, you know, if you have kind of a steel embedding another structure or helping support another structure, or perhaps you need a secondary material to serve as support structure, you know, that gets removed later, and maybe that material is easier to remove. Or going even further, you know, kind of thinking ahead into the future, perhaps now you can push the limits of innovation, and instead of creating single material products, you maybe start creating full-on product assemblies in one build, right? So the possibilities could be endless. Now, similar to Enlight, Aerosynth needed a system to test out their hardware. So again, we offered a solution, integrated the recoder, and got some really nice results. The results were pretty darn cool, I think. We were able to achieve multi-material parts, as shown here, with a copper and steel material. And so, play the video. In this video, so as I said, you have two rollers, each with a different powder or alloy, and each depositing onto a substrate selectively according to a CAD file, right? This particular option certainly has a lot of development needed still, right? It's very early in its release. I think we need to further extend the materials available with this unit, possibly push the number of materials. So instead of two, maybe 3, 4, 5 materials that can be deposited at once. And most importantly, you know, having a material science background myself, you know, what really deep analysis can we do to really evaluate the interface of these materials? We've done some of that already. If you want to learn more, definitely contact us, but still a lot of work and a lot of potential here as well. Finally, I guess similar to our flexibility in hardware additions is the flexibility in sensor additions, right? So we have done a ton of work, I guess, in the process monitoring area, not just as Econity, but working with our partners. Today we offer technically two different types of options, which I'll talk about. So coaxial or inline monitoring, basically coaxial to the laser beam, and then off-axis. So this first one shown here in this slide is coaxial monitoring, which basically splits the laser signal right here with a beam splitter, and then applies process monitoring on the back end, so it's able to look into that emission. So two options that have been applied here are pyrometry, as shown by the top right, and then, let me play that video, the bottom right, high-speed camera imaging. And so with high-speed camera, you're obviously able to get some really nice, you know, depictions of your melt pool. You're able to really gain a good understanding on your powder dynamics. So here you kind of see powder being sucked into this melt pool, which is really interesting, or just the, you know, kind of the jumping around of powder particles, and really has been used a lot to validate models and things like that, gain a better understanding of the process. And then with pyrometry, you know, you're able to, again, coaxially measure emissions coming out. And so what this has allowed is for us to see differences in energy input, right? So if you have a complex geometry, your scan vectors are shorter in one area, longer in another, you'll see a stark difference in the energy input, right? So you'll be applying more energy kind of in those short vectors because there's less time for energy to dissipate. But yeah, this has been a really cool option to, again, validate models. And then some people are trying to get, you know, what absolute temperatures kind of get to that more efficient parameter development type work. And then regarding off-axis monitoring, this really gives more of a global perspective, right? So rather than looking at the melt pool, you're now kind of looking at the entire process. And I'd like to say this is really well enabled by our open optical frame. So we have been able to add cameras and other sensors within the laser enclosure, as you can see here by the IR camera here. So we apply this type of approach to optical tomography as well, and then kind of sort of your typical webcam, let's call it, type monitoring, where you just have a simple camera looking at the process, right? But the last thing on this list, and the last thing I'll discuss today here, is using an optical microphone. And so in this example, we've collaborated with a company by the name of Zerion and implemented some of their hardware. So we not only added the hardware within our process chamber, as you can see here, but we also adapted our software to kind of record that data from their optical microphone. So here you see the type of data that we're able to get, both the raw and 3D spectrogram that it can really monitor down to what we feel are each single vector during a build. So I think this is pretty cool. It really has enabled a few different monitoring capabilities that in some cases are better than our on-axis or coaxial monitoring methods. So the 5 things I'll touch on here briefly, I'll review kind of the optical microphone being able to detect incorrect powder deposition, crack detection, recoder impacts, focus detection, and spatter or ejection detection. So first off, with incorrect powder deposition, we simulated anomalies in powder deposition by applying an insufficient amount of powder over a substrate. And, we were able to detect a loss of emission when powder was no longer being spread. And so this can certainly help during a build, especially in cases where powder runs out all of a sudden, right? So that's something that definitely has happened to me. Next is like crack detection, right? So this is a bit harder to simulate, but we have processed our fair share of non-weldable alloys. So we gave it a shot, and we've definitely been able to see something here as well. Now, we know cracking usually happens after exposure, right? Once the energy dissipates, there's all that stress, and then material finally gives. I guess luckily enough, this is exactly what we think we saw here. So we saw the exposure and then some emission of the optical microphone after that, and we think we did correlate that back to the build. So even more interesting, I guess, was that this anomaly was not detected by pyrometry or high-speed camera. So we did this build with both of those options installed, and again, that wasn't detected on those. So definitely a good sign for this type of device. Third is recoder impacts. This is probably a no-brainer, but if there is an impact to a part, then the emission of the sensor peaks, right? And this is exactly what we saw here, right? Now, the possibilities, similar to the incorrect powder deposition, can extend to the ability to detect anomalies during the process. But even more than that, I think it can also be used as an indicator that perhaps maintenance or servicing may be needed on the recoder. Yeah, that's just an example. Maybe if something needs to be lubricated, yeah, maybe that's caught by this monitoring method. And then next is an interesting one. So this is focus detection. And so, yeah, maybe I'm the only weird guy that has put his ear to the window of a laser powder bed fusion, a window, right? But if you guys have done it or do it, and you listen very closely, you know, kind of take out all the other noise, maybe if you can, you'll find that the sound of the laser melting metal powder essentially sounds like a nice set of eggs cooking in a frying pan, right? At least that's my opinion. I don't know, you could just listen in and judge for yourself, but I guess apparently you could apply this to this microphone, right? And if you apply different focus values, you get different melting sounds. So this again, you know, if you were to plot this, you get maybe the Scott's profile in sound, or sorry, bell curve in sound. And maybe at the optimum focus, you're right at that peak of that bell curve, right? So this has a potential for a quick diagnostic of laser focus again, or maybe as an auto calibration, right? So if it's integrated in our software, you can do a quick scan and potentially narrow in on whether your system's focused or not. And then finally, something that may need a bit more correlation is the detection of abnormal spatter. This again can be used to compare to a normal process. Maybe, you know, if you know how a normal process may sound, you know, kind of my example with the eggs cooking in a frying pan. If it sounds like I don't know, a steak cooking, then it's not the same, and now your process is deviating from that normal process, right? So this is all really cool stuff that we were able to integrate with Xerion and their optical microphone. But yeah, so to conclude, you know, at least I hope more people got to know Econity a bit more, and you know exactly what we do and what we offer, and really how we differentiate ourselves from others. So today I've gone through a handful of different success stories. You know, I could have probably gone through more, but I already felt this was a lot of content, kind of, you know, in a few different directions. So definitely didn't want to overwhelm, but yeah, as I mentioned earlier, we are growing our presence here in the U.S., and we very much are open to collaborating, especially as we increase our applications engineering activities here in El Paso. Definitely please contact me if you have more detailed questions, or maybe you want to learn more. I probably don't have the answers to everything. We could get our team in Germany involved, but we can at least, you know, definitely start a conversation. Anyway, yeah, thank you, and I'm ready for questions if there are any, Jason.
All right, thanks, Jorge. We'll now head into the Q&A session. If you have a question and you have not done so already, please type it into the Q&A box, or you can send it to me in the chat. I can pick them up there as well. I do have a couple questions here I can get started with. So are your machines exclusively for research, or can they be used in a production setting as well?
Sure. So Econity originated, I guess, as a company to facilitate some of these research ideas that we were being restricted by these, you know, I've been calling them typical box systems. But we've had a long history with universities and research centers. That said, I think we're growing as a company, and it will be inevitable to move towards these industrial applications. We're already doing this now, both here in the U.S. and in Europe, and you know, kind of targeting some specific applications where we can help in production. So this is definitely an area where we hope to continue to grow in. Yeah.
All right, thank you. So you got another that came in. How do you handle multiple laser calibration?
Yeah, good question. So the calibration of multiple lasers is pretty important, as you probably know. I mean, you saw in the video kind of the 8 or infinity pattern scanning with the secondary beam kind of following along with it. So these lasers have to align to really a micron resolution. And so the good news is that our company is an offspring of the Fraunhofer Laser Institute. So as a result, our engineers are laser experts, right? They typically come from that institute. So maybe to half answer that, you know, we achieve this via an elaborate calibration consisting of sensors integrated into our software. But yeah, this is, I encourage that you guys contact us about that further. Mm-hmm.
Okay, and let's see. As for like powder suppliers, if someone did have an economy system, can they work with any powder supplier?
Yeah, yes. So the simple answer is yes. The long answer is that we actually encourage our customers to work directly with powder suppliers, kind of explore what's out there. I think this leads to customers having more of a deeper collaboration with the powder supplier and really just an overall better understanding of the feedstock that they're buying, right? Maybe they're targeting a specific chemistry and they know exactly, you know, maybe they don't know what affects it, but by talking to them directly, they can tailor to their needs. Anyway, but yeah, we're definitely happy to sell powder to anybody.
All right, thanks. And then just for informational purposes for those in attendance, what process could they follow if they would like to work with Econity or if they wanted to explore a new application?
Sure. So there's definitely different avenues. One way, and perhaps preferred for us, is obviously to buy a machine and work within your own facility. Maybe you get help from us as you work on that. But if you perhaps want to try something out, you know, before buying a machine, then we could work that through our team in Germany. We probably won't do applications work for free, but you can at least, we may be able to work out a deal where, you know, some of that cost for that applications work goes towards the purchase of a machine, assuming everything's successful, right? Then the last thing is, you know, like I said earlier, we're growing our presence here in the U.S. So that's an area where we hope to support customers here. And so the structure would probably follow the same as what I just mentioned, working with a team in Germany there for a charge in hopes that it leads to a machine purchase.
All right, great. Thank you very much. All right, so I think that's all the questions we got today. So I guess that'll wrap up today's TRX webinar series. I do want to once again thank you, Jorge. That was a great presentation. If anybody in attendance does have further questions, you can reach out to him directly at the information on the screen. And there will be a post-webinar survey going out to all of those who participated. We do really appreciate the time that you take to provide America Makes feedback so that we may continue to improve and strengthen the additive community. And as a reminder, if you think that you or your organization will be interested in sharing on the TRX webinar series, please fill out the form that follows the presentation, or you can reach out to myself, Jason Thomas, at jason.thomas@ncdmm.org. Thanks, everyone. Have a great day.
Thanks, Jason. Yep. Bye-bye.
Thank you. Bye.